Hi everybody. In this next section we're going to talk about how to use formulas, or what are known as literal equations, to solve problems. And so these won't necessarily be word problems so much anymore, but all the equations should still be linear. So you would want to solve the equations basically the same way we did back in section 1.1, and that is mainly, try to add things to both sides or do the same thing to both sides to get the thing that you're solving for alone. Now, the thing that can make this a little bit more difficult is you may have more than one variable, right? And it may not always be clear what variable you're supposed to solve for. So, for example, you might have an equation involving maybe A and P and Q, and so the question is, do you solve for A or P or Q? So these problems might look more difficult, but essentially you're using the same method that we used in section 1.1. So like I said, the thing that makes, and we'll look at some examples of formulas here in just a minute, but oftentimes an equation may contain more than one variable. These types of equations are called formulas or literal equations, right? Because they have lots of letters in them. And so the types of equations that we're going to solve in this section will be types of equations that you might encounter in some of your other classes, like such as chemistry or physics or economics or business or something like that. And like I said, solving formulas is very similar to solving equations with one variable, which is what we studied in 1.1. So again, we're going to use the exact same procedure we've used in 1.1, except it'll be a little bit trickier because the equations will look more complicated. But if you think back to what we did in section 1.1, right, I mean, basically you want to simplify both sides first, and then try to get everything with the variable that you're solving for on one side and everything else on the other side by adding and subtracting typically, then simplifying again. Then if there's a number or a coefficient in front of the variable that you're solving for, divide both sides by that. And then in this case, you can check your answer, but it won't be quite as easy. So here's some examples of some types of formulas that you might encounter in this section or your other classes. And the idea in this case is that you don't really have to understand what the formula stands for in order to solve it. Like, so for example, this first equation is pretty simple, right? They give you the equation d equals rt. Who knows what that stands for, but they want you to solve for time. So what you would basically do in this case is just divide both sides by r to get the t by itself, right? So although this might look complicated, it's actually relatively easy, right? And this equation is actually probably the equation for distance equals rate times time. But again, you don't have to know that in order to solve the equation, right? You just have to rearrange the equation. Here's some other formulas that you might remember. This is maybe the equation of a line. You might remember that. This is an equation that you might see in statistics. And again, these sort of special symbols here, these Greek letters, might sort of intimidate you, but they're really just symbols, right? So like this one you would solve very similar to what you would for a linear equation. This is a formula for compound interest. This is the formula for converting Celsius to Fahrenheit temperature. Here's another equation of a line. But the idea is we'll take formulas like this and learn how to solve them. So here's some other examples of formulas that you might see. You might have like formulas for area or volume. An example that would be something like the area of a triangle is equal to its length times its width. You might see some of these formulas in physics, such as the formula for kinetic energy, K equals m times v squared over 2. And again, I'm not expecting you to memorize these formulas or anything. But I will let you use a formula sheet on the written exams. So you can certainly copy these formulas down if you want to. But the important thing is that you know how to solve them. This would be similar to a formula we used maybe in the last section to calculate your average grade. This would be an equation from finance or business or something like that. So there's lots of places where you might run into these types of equations. We solved some simple examples here, but let's maybe look at something that's a little bit more complicated. Let's say that you take this equation here, y equals mx plus b, and you want to solve for m. And so you have to be kind of careful with these problems because you might look at this equation and automatically assume that you're supposed to solve for x, but since there is more than one variable, you'll have to be told what to solve for. So essentially what you want to do is get m by itself. So the first thing we'll do is subtract b from both sides. That'll get the b on the left-hand side. And then we just have to get m by itself. So the next thing to do would be divide both sides by x, and then that's your answer. And you can actually check this if you want. If you do plug this in for m, you will get y on both sides, but I'm not going to expect you to do that on the exam. Like I said, one of the places where you'll see these formulas is in geometry. And so, again, these formulas that I'm about to show you on the next slide, these might all be formulas you might want to put down on your formula sheet. Maybe just to go over these to remember, help you remember these. If you have a square with side s, the formula for the area of a square is the side times the side, right? Basically the length times the width. The perimeter of the square, which is the distance around the outside, is going to be s plus s plus s plus s, or in other words, 4s. For rectangle, the area you might remember is the length times the width, but the perimeter is twice the length plus twice the width. For a triangle, one formula you can use for the area is if you know the height of the triangle, the area is equal to 1/2 the base times the height. For perimeter of a triangle, right, if you have sides A, lengths A, B, and C, the perimeter is just what you get when you add up all three sides of the triangle. Remember, we have other geometric figures such as a trapezoid. Remember, the area of a trapezoid is 1/2 the sum of the two bases. This is base little b up here, but you have the big base, which is denoted by capital B, and the little base, which is denoted by lowercase b. You take 1/2 that sum times the height, and then that gives you the area. Right? The perimeter of a trapezoid is basically what you get when you add up the lengths of the sides, and there's no guarantee that the sides will all be the same length. Like on this trapezoid, it may seem like this length is the same as that length. So if you add side A, B, C, and then sometimes I'll call this side D, but I guess we're calling it capital B in this case, that would be the perimeter. For a parallelogram, in this case, if you know the height of the parallelogram, the area of a parallelogram is just the base times the height. You can kind of think of that if you were to chop this triangle off and stick it on over here, it would give you a rectangle. So that's the formula for the area there. For perimeter of a parallelogram, since these sides are the same length, it'll just be 2a plus 2b. For a circle, remember the area is pi r squared, where r is the radius. Remember, pi is approximately 3.14. We'll use that for an approximation in most cases. Most calculators have a pi button on them if you need to carry it to more decimal places, or people will sometimes use 3.14159, but I'll try to tell you what value for pi that you should use. Pi is one of those numbers you can't really write down exactly. The circumference, which is kind of like the perimeter of the circle, the distance around the outside, is 2 pi times the radius, or pi times the diameter. For a cube, remember the volume of a cube, the amount of stuff inside the cube is just the length times the width times the height. And for a cube, right, the length, width, and the height are all the same. In this case, we're calling them s, so it would just be s times s times s, or s cubed. The surface area of a cube, each face of the cube will have an area of s times s, and a cube has 6 faces, right? 4 for the sides and 1 for the top and the bottom. So the surface area would be 6s. For a rectangular solid, like a box, the volume is the length times the width times the height. The surface area then is what you get when you add up all the areas, right? So the area of this face would be the length times the height, and then there's the same surface on the back side, so you'll get 2 times that. And then same thing for every other surface. The area of this surface will be the width times the height. You've got another one on the back, so that'll be 2 times the width times the height. And then the top then will be the length times the width, just double that. So it's just 2 times the length times the width, plus 2 times the length times the height, plus 2 times the width times the height. For a sphere, remember the volume of a sphere is 4/3 pi r cubed, and the surface area of the outside of the sphere, again, is 4 pi r squared. I guess the way I remember that is that a sphere can be covered with 4 circles, right? Because remember, the area of a circle is pi r squared. Other geometric figures you might remember is a circle or a cylinder. The volume of a cylinder is just pi r squared times the height. So imagine you're taking the area of the top of the cylinder or the bottom and you're extruding that a length h. You're basically taking the area of the base times the height. Surface area of a cylinder is a little bit more complicated. Basically what you have is you have the surface area of the lateral surface area, sort of the area that's perpendicular to the bottom, which is essentially going to be the circumference times the height. So remember, the circumference of a circle is 2 pi r times the height, and then the end caps, the top and bottom of the cylinder, are both circles, which have an area of pi r squared. So the area of the top and the bottom will be pi r squared. So you'll get 2 pi r squared for the top and bottom of the cylinder, and then 2 pi r h for the sides of the cylinder. And then the volume of a cone is basically 1/3 the volume of a corresponding cylinder. So if you were to make a cylinder out of this cone, right, the volume of the cone would be about 1/3 the volume of the corresponding cylinder. And there's no easy formula for the surface area of a cone, so we won't really worry about that. So again, you might want to just copy some of these formulas down on your formula sheet in case you need them. I may provide them to you, but it certainly wouldn't hurt to copy those down. I should mention too that most of these formulas I think are found in the inside back cover of your book if you need them. So let's look at maybe some applications involving these formulas. So let's say that a sailboat has a triangular sail with an area of 96 feet and a height of 12 feet high. What is the length of the base of the sail? Right. So we want to identify the geometry in the problem. Right. We're looking at the length and the base of a triangle, and we have the area. Right. So you probably want to use the formula for the area of a triangle. Remember that formula is area equals 1/2 the base times the height, and we have the area and the height, and we're looking for the base. So in this case, what you'd want to do is use this formula. Again, the area was 96 and the height was 12, so plugging into that formula, solving for this, just take 1/2 of 12, which is 6, and then to solve for b, just divide both sides by 6. And 6 happens to go into 96 exactly 16 times, so that would mean that the value of b then in this case is 16. A couple other things to keep in mind is you can check by plugging that back in there, see if you do get 96 in this case, and then don't forget your units. I guess if you just leave 16 on the exam, I probably won't take points off there, but if you just write down 16, people won't know whether you're talking about 16 feet or 16 meters, so it's always a good idea if you put the units down, right? Bad things have happened when people forgot to put their units down. I remember one student telling me that they wanted to order some dirt for their garden, and it was a 10 by 10 foot garden, and they ordered, instead of ordering like 10 square feet of dirt with a little bit of thickness, which would give you a little bit of volume there, they ordered 10 cubic feet of dirt, and when they got home at the end of the day, they had this huge pile of dirt, way more than they needed. So I guess at least they had plenty of extra dirt, but they probably spent way more than they needed to also. Susie is making a planter out of an empty can for Mother's birthday. So let's look at another example here involving cylinders. So she has 157 cubic inches of soil to use. Find the radius of the can if it has a height of 8 inches. Okay, so in this case we're dealing with cylinders, right? We want R to represent the radius of the cylinder. So remember, the volume of a cylinder then is just pi times the radius squared times the height. We're given the height and the volume, and we want to find the radius. So solving for R, if you take 8 times pi, or you use 3.14 for pi, that will give you a value of about 25.13. So divide both sides by 25.13, and then take the square root of both sides to get 2.5. So the square root of 6.24 is about 2.5. So in that case, the answer would be about 2.5 inches. And again, you can always check that by plugging that in. Maybe just to look at some other applications involving cylinders. Here's something a little bit more complicated. Let's say that you've got, again, remember the surface area of a cylinder is given by this formula. So let's say, for example, we want to solve this formula for H. And then once we've done that, determine the height of the cylinder if the surface area is 100 square inches and its radius is 2 inches. And let's say you want to use 3.14 for pi. And there are a couple different ways you could do this problem. You could immediately plug 100 in for A and 2 in for R and solve that for H. But you might want to rearrange the formula first, especially if you have to do this calculation for lots of different areas and radiuses. So, for example, you could even write a computer program where all somebody has to do is type in the area and the inches, and it would compute the height of the cylinder. And so in order to do that, you could just solve the equation once and put that into the equation. But whichever way you want to do it is fine. But I just did this one by solving the equation first and then plugging in the numbers. You can plug the numbers in first and then solve for h. But doing it this way kind of solves all the different equations at once. It's maybe a little bit harder because it's a little bit more abstract. But I think in the long run it'll help you. So again, we're trying to solve for h, so we want to get everything without an h on one side, right? Well, this term does not have an h in it, so subtract that from both sides. And then to get h by itself, we'd want to divide both sides by 2 pi r. So if I divide this side by 2 pi r, it'll cancel with itself. And here I'll divide by 2 pi r, right? You have to be a little bit careful here, right? Because you cannot cancel the pi's or the r's because you don't have a pi and an r in this term. So you'd want to just leave it like that and then just plug in your numbers, right? Remember, a was 100, r was 2, and then just work that out and see what you get, and you'll get that the height is about 5.96, and I forgot my units here, I guess, right? That would be in inches. And you can certainly round that to however many places you want. I'll try to let you know on the exam how many places to round to. If I don't say otherwise, you can assume that you're rounding that to 2 places, or you can just ask if you want. A couple other things you might encounter in this section is different types of angles or terminology related to angles. One is the supplement of an angle. So two angles are said to be supplements of one another, or said to be supplementary if the sum of their angles is 180 degrees. So in other words, if you add the two angles together, you get 180 degrees, which is sometimes called a straight angle. So if you've got like angle A and angle B, if those two angles add up to 180 degrees, right, those angles are said to be supplementary of one another. And two angles are complements of one another, are said to be complementary if when you add the angles together you get 90 degrees. So like for example, if you have two angles A and B that add up to a right angle or 90-degree angle, those two angles are said to be complementary. And it's hard to maybe remember the definition of these two. Again, you can write these definitions down on your formula sheet so you don't forget. Because one student has a mnemonic that I knew had a mnemonic device for remembering this, and C comes before S, and 90 degrees is less than 180 degrees. So I don't know if that helps you remember that or not, but anyway, so let's look at an example here. So let's say that one angle is twice the measure of its supplement. Find the measure of the two angles. So you have two angles here, right? Maybe let's call this angle X, and then you have this other angle here, and I guess maybe I should call this one X over here. And this angle here is twice as big as whatever its supplement is over here, right? So if you think about it, the supplement here would be 180 degrees minus whatever X is. So this thing here is twice what that is, right? And so it can be kind of hard to set this up because you might wonder, well, what do they mean by the supplement of the angle? That's all they mean, right? Is that if this angle is X, the other angle is 180 minus X. So if the first angle is twice the supplement, this would be your equation. So then just go ahead and set that up and solve. And again, you might be able to get the answer for this by just doing a little bit of algebra here. If you set this up and solve it, though it should give you the right answer. So distribute the 2, you'll get 360 minus 2x. Add 2x to both sides, you'll get 3x is equal to 360, and x is 120, right? So that means the two angles then would be 120 and 60, right? And you want to find the measure of both angles, not just the one. And that does make sense, right? I mean, this angle is twice as big as the other one, and these two angles are supplements of one another. So this can be a little tricky to set up. If you need to do this without algebra to kind of figure out the answer, you could sort of do that and then go back and do it algebraically if you want. But I would prefer if you would do those things algebraically, especially on the exam, because remember, I will give you work for partial credit. If I just see an answer pop out of nowhere, I might give you full credit, but there's no guarantee. So try to get in the habit of showing as much work as you can. Let's maybe look at one last application here involving the perimeter. Remember the perimeter let's say that the perimeter of a rectangular window is 26 feet, right? So we've got this rectangular window. I don't know how it's oriented. The length of the window is 3 feet more than its width. So you've got the width here, and the length in this case is whatever the width is plus 3, right? And typically the length will be longer than the width, although some books don't really make that distinction. There might be instances where the width is longer. I guess it doesn't really matter which dimension you call the width and the length. what are the dimensions of the window, right? In other words, what is the length and the width? Well, so remember the formula for the perimeter of a rectangle is it's 2 times the length plus 2 times the width, and we know that the length is 3 feet more than the width, and I just noticed I had a mistake here, right? So we could replace the length with w plus 3, right? And we want to write everything in terms of one variable here. So that's going to affect my answer here, so sorry about that. So if I distribute the 2 through, right, this will become a plus, and then this will become a plus. So I'll get 2w plus 2w, the 4w is okay there. So I guess I'd want to subtract 6 from both sides, so this would actually be a 20. And then dividing both sides by 4, I guess I'd get the width is 5. So the width would be 5 here. And then the length would be 3 more, right, which would be 8, I guess, right? So this would be 5 plus 3, or 8. And then don't forget your units, right? This would be 5 feet and 8 feet. And so that's why it's a good idea to check your answer here, right? I mean, I made a silly mistake here. I guess if you tried my original answer, which was 8 feet and 11 feet, right? If you did 2 times 8 plus 2 times 11, right? I don't think that gives you 26, right? Yeah, because you get 16 plus 22, right? Which would be way big. The perimeter would be too big there, right? It'd be 38 feet. So I should have known something was wrong there, right? But if you use 5 and 8, I think that does work out. So 2 times 5 plus 2 times 8, right, gives you 10 plus 16, yeah, which is 26. So it's always a good idea to check your answer, right, because it's possible to make silly mistakes like that. So sorry about that one. There should have been a plus 3, right, because the length is 3 more than the width, not 3 less. Okay, well, I hope that helps you guys out with that section. If you guys have questions or problems or anything, just let me know.